The initial Illumiroom system was created in 2013, and a paper was published explaining the concept. We will be using the research from the original system to create our Illumiroom clone project. The purpose of the project is to expand the immersiveness of gaming experiences with TV and projector, and we hope to implement various custom selected modes for certain games and generalized modes for any game. We'll use a webcam instead of Kinect, as was originally used. 2 videos were created for the Illumiroom project, and these were uploaded on YouTube, and these will be linked below, so feel free to have a look. The Philips Ambilight system uses LED strips placed around a TV. The system can either be built into a TV or added, and it works by intercepting the video signal and turning on the correct light colours. I'll let this demonstration show you what I mean.
For more accurate projection results, the initial calibration process requires us to generate a depth map. And while there are many ways to go about creating one, we want ours to be as easily accessible as possible, without requiring any special equipment. So for a good mix of reliability and ease of use, while still using just a webcam and a projector, we can opt in for a technique called structured lights, a variant of which was actually used in the initial Kinect design. It involves projecting various patterns and using triangulation between the expected outcome and the camera footage. There are many different types of projection patterns that can be used, each with their own strengths and weaknesses, an example of which, called fringe patterns, often used in 3D scanning, can be seen in the video. I used OpenCV to generate and capture a phase-shifting sinusoidal pattern that can be later transformed into a point cloud, giving us a depth map for more accurate projection mapping.
An interesting problem exists. How do we read in and process game data to allow us to display the correct effects? Do we hack the game's memory? This could be quite difficult in closed-source mainstream games, which try to deal with cheaters by implementing anti-cheat. Do we use computer vision, or do we use API? Again, unlikely to be accessible. Do we use computer vision of screen content? This might work, where I've found a number of libraries which could be helpful, including Pi image search. More about this in a minute. Do we read controller inputs and potentially vibration output? It's possible, but I'd need to look into this further and potentially find a way to intercept the game signals before they reach the game. And finally, we could analyze game sound to hear when loud sound effects occur. Pi image search is based on OpenCV, and we'd be able to use it to take screenshots, analyze the game content, and dispatch actions to the Illumiroom projection system to display the correct effects. And we could also make use of sound detection using a library called Librosa to detect loud sounds such as gunshots, car crashes, or goal noises in Rocket League, for example.
The depth map can be used in 2D projection mapping, where the aim is to render the view to be projected onto the irregular surroundings behind the TV from the user's viewpoint. I found the mapping process used in Illumiroom was explained in Microsoft's Room Alive toolkit. First, a projection matrix is computed for the user's projector. Mason's Projections in Context paper argues that the perspective projection is the most realistic as it closely resembles human vision. Currently, there are open-source graphics APIs for assembling this matrix, such as Microsoft's Direct3D, OpenGL, and Vulkan, though Vulkan is too low-level for our use. For simple 2D mapping, Room Alive used Direct3D through SharpDX, a .NET wrapper of the DirectX API. SharpDX is relatively stable, but hasn't been maintained since 2019. For complex 3D mapping in Room Alive, Unity scenes were created to perform view-dependent projection, so we could utilize Unity with the DirectX to create 2D scenes. Next, transformation matrices are computed using the projection matrix, pose data on the depth map and the projector, and the user's point of view. Then, the shaders from the graphics API and the transformations are used to render the view, producing Illumiroom's illusions. Illumiroom uses a focus plus context display with a high-resolution TV and a lower res projector. This is useful as the peripheral vision is poor at identifying distinct objects and is more receptive to motion. From Illumiroom's user study, the focus plus context selective and segmented illusions were favorites, as they gave game content without distracting. Peripheral flow illusions use the motion of the game's camera when they couldn't access its source code. Among these, illusions like radial wobble and bounce were appropriately immersive. When generating ideas for our projection designs, the user study results will be used with the examples provided by Projection Mapping Central, referenced in the Illumiroom paper.